My mill started making some funny sounds, and pretty sure it's broke down.
Sick and tired of working on this thing.
So you have this 30-foot long roll with bearings on either side of it. It's going to want to sag. It's 30 feet long. I'm Courtney with JTEKT, and today we're going to talk about spherical roller bearings. So what is a spherical roller bearing? Well, we're going to start out, here's a spherical roller bearing. Typically it's going to have 4 components. It's going to have your outer ring, your inner ring, your cages, and your rollers. And why is it called a spherical? Well, the spherical shape of the roller. And just like our other ball and roller bearings, the outer ring, the inner ring, and the rolling elements are all going to be made out of 52100 steel. The cage is going to be made out of that brass material, or it's going to be made out of this steel material. What size range? These go from 25 millimeter bore, all the way to over 500 millimeter bore. So typically only metric product. So again, when we look at spherical roller bearings, their bore size is typically going to be a metric call out. Spherical roller bearings, it's going to have 2 sets of spherical rollers, and these rollers will have a spherical shape to them. So as you can see down here, this roller is not flat across, it's going to have a spherical shape. That spherical shape matches with the spherical bore of this outer ring. So I can take this bearing and I can actually pivot it back and forth inside here because those rollers are spherical. So I can make a perfect sphere all the way around. So and there's different rib configurations, and when I talk about that, I'm talking about the center guide flange. So it's how we separate these rollers. And even with these 2 designs, you can see we have 2 different style type cages. These cages are basically what guide the rollers. Typically will also guide the rollers along with the cage. So spherical roller bearings, they're designed to take very high radial loads. So just like cylindrical rollers, very high radial loads. You can see there's 2 sets of rollers inside here. Now, can they take any axial or thrust load? Yes, they can, but not pure axial or thrust load. The amount of axial or thrust load they can take is relative to how much radial load. So the higher the radial load, the more you can take axially. If you don't have any radial load on the bearing, you can't mount this bearing and put an axial load on it. What will happen is you'll drive the edges of those rollers into the race. So you have to basically seat the rollers with that high radial load if you want to put any type of thrust load on the bearing. Now, what's the really unique thing about a spherical roller bearing? It's its ability to misalign, dynamically misalign. So what I mean by dynamically, while the bearing is rotating. So this bearing, that inner ring, you can see the rollers can oscillate back and forth. So that inner ring can actually wobble up to 1.5 degrees in either direction. So I'm over exaggerating that. The rollers can't come outside the outer race, but we can actually pivot this bearing up to 1.5 degrees in either direction. You can get these with a tapered bore. So what does that mean? That means that the bore of this bearing, this part right here, I can actually, instead of it being straight across, I can get it on a slight taper. So that means that one side of this inner ring is going to have a larger bore size than the other side. There's going to be a taper inside there. Why do we have that tapered bore? That's going to be for installation. So a lot of times that tapered bore is going to match up to what we call a tapered sleeve, and allows us to put a metric bearing on an inch shaft. And how do you do that? Well, you get a sleeve that goes underneath. That's got an inch bore, the sleeve does, and we're able to push a metric bearing up that sleeve, lock it onto the shaft by using a nut that will push that bearing up the sleeve and lock it. If it's a straight bore, then we mount it by just heating up the bearing and putting it on the shaft that way. Now, just like the cylindrical roller bearings and angular contact ball bearings, these can't be sealed or shielded. So obviously, because of this misalignment, there's no way for us to put a seal or a shield on here. So you'll have to find another way to lubricate the bearing. So why use a spherical roller bearing? Well, it can carry very high radial loads. Okay, I like to use the word heavy duty. Okay, so when I see a spherical roller bearing, I'm thinking this is a heavy duty application. It's a big, heavy duty, seeing a tremendous amount of radial load. It's got 2 sets of big rollers, so it's going to see a lot of load, a lot of radial load. What I also see is this dynamic misalignment. So when you have those very high loads, a lot of times what will happen is that shaft will deflect. It might bend some, it might sag, even though it's steel, it's still able to sag when you have tremendous amounts of load. And so having those rollers being able to pivot a little bit inside there will allow that shaft to sag and not unload those rollers or load those rollers up incorrectly so they can't carry the load. So the other nice thing about spherical roller bearings, why I use those? Because it has a wide breadth of product. So we have this one bearing here that has a certain bore size. We have 5 other types, 5 other sphericals that will have a different OD and a different width that'll fit on that same bore. So it has a very wide range of product that you can use with spherical roller bearings. So where are spherical roller bearings used? Well, these were designed initially for paper mills. So why in paper mills? In a paper mill, you have a roll that the pulp is going through that's getting compressed and you're turning it into paper. Well, these rolls, this roll here is 30 feet long. So you have this 30-foot long roll with bearings on either side of it. Well, what's going to happen with that roll? It's going to want to sag. It's 30 feet long. So when it sags, that's going to want to pivot, that shaft is going to want to pivot inside the bearing. And so if that inner ring cannot pivot along with it, again, it's going to load up those rollers funny. It's going to load up the edges of those rollers and it's going to fail the bearing prematurely. So the paper mills were the first, they were what spherical roller bearings were designed for. Now from that, because they're such heavy duty and there's so many heavy duty applications with long shafts, spherical roller bearings were being used in wind turbines. So when you see that big windmill or a wind turbine, those huge blades, right behind those blades is a big spherical roller bearing. If you look at that bearing behind me, you can see how big spherical roller bearings can get. And again, why? Because that shaft will actually bend a little bit, and there's tremendous radial load from those blades hanging down on that shaft. Where else are they used? Head and tail pulleys for conveyor equipment. So if you've ever been driven by a sand and gravel pit, you'll see these conveyors that are carrying sand or rock and they're kind of dumping it into a pile. Well, at the very top of that conveyor, we call that the head, okay? And at the bottom is the tail, are 2 bearings supporting that and 2 bearings at the bottom. Those are typically spherical roller bearings. Large fans will use spherical roller bearings. Steel mill casters and steel mill trunnions. So what's a caster? A caster is the part where we pour the liquid steel and it goes down this chute and there's these rollers all the way down that are kind of forming that liquid and making it semi-solid before it gets to the major rollers. Each of those rollers are going to have a spherical roller bearing in it. The trunnion is the bearings that are the part of the huge pot that pours the steel. So imagine a huge pot that's 2 or 3 stories tall, that's 30 or 40 feet wide, and it's got these trunnions, or like half shafts that stick out. These spherical roller bearings will be on either end of that shaft. And again, why? Because that thing is going to sag once it's full of steel. So those things are going to sag, and you need that spherical roller bearing to be able to dynamically misalign. Another heavy-duty application is a car crusher and those types of equipment, rock crushers. And again, a car crusher has got a shaft and it's got all these big hammers on it, and it's spinning around and it's going to be crushing cars and buses and whatever else. And so huge amounts of radial load, a very long shaft, right? Because the cars and the stuff have to fit in there, so you're going to have that misalignment and heavy radial loads. Thanks for sticking with us through this crash course on spherical roller bearings. We've covered the key components, their role in handling misalignment, and how they excel under heavy radial loads. Stay tuned for more bearing training from JTEKT, formerly known as KOYO.